Good morning. Talk about completing the square. Here is some trivia about the square root symbol that we'll be using a lot in this discussion. Do you know that the square root symbol was first used in print in 1525 in the book of Christoph Rudolph? Rudolph was the author of the first German textbook on algebra, and he used the meaningful definition of x to the 0 equals 1, or any number raised to 0 equals 1. This happened in 1525, that was 4 years after Magellan circumnavigated the world and landed in the Philippines. So, completing the square. We can think of completing the square this way. We have these algebra tiles with, let's say, the length of this is x. And so we can say that the area of this square is x squared. The length here is 1 unit, and this length is also x. That's why you have x times x equals x squared. If this is x, and this length here is 1, that means the area of this green rectangle is x. And this other rectangle is congruent to that rectangle. So this has also an area of x. And there is a missing square here to have a complete the square. That is exactly the scenario here in completing the square. There is a missing square here, which is this one. And our task is to find what is this square that's missing so that we can complete the square. And if the numerical coefficient of the squared variable is 1, the length of this missing square is 1/2 of whatever is the coefficient of the x term. And so what is 1/2 of 2? 1/2 of 2 is 1. So this side length here is 1. And since this is a square, this length here is also 1. So what we are looking there for now is this smaller square, which is 1 by 1 or 1 squared. And by doing so, we have just completed the square. And once we completed now the square, you now have this missing square completed. So we now say that we have completed the square. But before we talk about all the details, let's start first with the question, why do we need to complete the square? To answer that, consider this equation. Suppose you have x squared minus 25 equals 0. Find the value of x that satisfies this condition. What we can do is we're going to use the square root property. The square root property says that if x squared equals a, then you can take the square root of both sides and you will get x equals plus or minus the square root of a. So we can use the square root property in order to solve this equation. By adding 25 to both sides of the equality, we will have x squared equals 25. And by applying the square root property, we can take the square root of both sides and we will get x equals plus or minus 5. This means x equals positive 5 or x equals negative 5. When you have cases like this, sometimes you have an extraneous root. So we have to substitute these values back to the equation and check if we have the correct equation. So if x is 5, you have here 5 squared minus 25 equals 0, which is correct. If x equals negative 5, we have negative 5 squared minus 25 equals 0. Negative 5 times negative 5 is positive 25 minus 25 equals 0 is also correct. So in this case, both x equals 5 and x equals negative 5 are solutions to the equation x squared minus 25 equals 0. And we solve this using the square root property. We have this scenario where you have the quantity x plus 3 squared equals 36. Even if you have a binomial raised to the second power, we can still use the same square root property to solve this equation. So what we will have is, we get the square root of both sides, and don't forget to put plus or minus sign here, and we'll be able to cancel the exponent. So what we have is x plus 3 equals plus or minus 6, which is the square root of 36. And then solving now for x, we subtract 3 from both sides. So we have x equals negative 3 plus or minus 6, which means x equals negative 3 plus 6, which is positive 3, or x equals negative 3 minus 6, which is negative 9. So we find the solution to this equation by using the square root property. But what if the situation now is like this? We have x squared plus 10x equals 11. We want the left side to be the squared variable, but we cannot just move this 10x to the other side because this has a variable x. What we want to do is gather all the variables to one side of the equation and gather all the constants to the other side of the equation. So at the left side, we have x squared plus 10x. At the right side, we have 11. But our problem is we cannot apply the square root property because this is not a perfect square trinomial. So there is now a need for us to find that missing term to be able to complete the square. That missing term that we are looking now here is equivalent to this square that we need in order to complete the square. And so that's the reason why we need to complete the square, so that we can turn this into a perfect square trinomial, and then later on we can apply the square root property. So this is now the process in order to do that. Let's say the problem is find the value of c that makes x squared plus 16x plus c a perfect square. There are 4 steps that we are going to follow. We first write this one, x squared plus 16x. That's the first step. Next, we are going to find 1/2 of b. Notice that b is whatever is the coefficient of the x term. So we want that 16. Not the x squared, but the x term. So 1/2 of 16 is 8. So we now write 1/2 of 16, which is equal to 8. This 8 is what we need in the next step. In the third step, you square the result in step 2. What you're going to do is square that 8. 8 squared. And then add this result to these first 2 terms. So the perfect square trinomial now is x squared plus 16x plus this one, 8 squared. And the factored form of this would be, get the square root of this first term. So the square root of x squared is x. Copy this sign. If this is plus, you put plus here. If this is minus, put minus here. And then disregard this. Get the square root of 8 squared. The square root of 8 squared is 8. But notice also that the square root of x squared is just the same as getting 1/2 the value of this coefficient. And what is 1/2 of 16? That's 8. So therefore, the value of c to complete the square here is 8 squared. So c equals 8 squared or 64. We're going to use these skills in order to solve our problems involving completing the square. So let's go back now to the problem we were trying to solve a while ago. So to complete the square now here, we'll have x squared plus 10x isolated at the left and the constant isolated at the right side of the equation. And then we are going to complete the square by getting 1/2 of 10. 1/2 of 10 is 5. And you square this 5, that's the term that you are going to add here, 5 squared. If you add 5 squared at the left, you are going to do the same at the right side by applying the addition property of equality. And then once we added that constant, the next step is to factor. We know that the factor of this perfect square trinomial would be a binomial raised to the second power, or a square of a binomial, where the first term would be the square root of this x squared, which is x. The sign is this plus sign. And the second term of the binomial is 1/2 of 10, which is 5. And you can get also that 5 by getting the square root of 5 squared, which is also 5. So this entire trinomial is now factored as the square of the binomial x plus 5. So we have taken care of the left side. We go to the rest of the equation. So equals 11 plus 5 squared. What is 5 squared? 25 plus 11, that's 36. Now this form is familiar with us because we can apply the square root property that we talked about in the previous slides. So we can get the square root of both sides. What we have at the left is x plus 5, and at the right side is plus or minus the square root of 36. What we did was we take the square root of both sides. And then we know what's the square root of plus or minus 36. That is plus or minus 6, because the square root of 36 is 6. Copy the equality sign, copy the x plus 5. And then finally, for our final answer, we have x equals, subtract 5 from both sides, we'll have negative 5 plus or minus 6. And this means x equals negative 5 plus 6, which is 1, or x equals negative 5 minus 6, which is negative 11. So we now say that the roots of x squared plus 10x equals 11 are x equals 1, or x equals negative 11. Let's have another example. If we have x squared minus 10x plus 25 equals 27, find the value of x. When you have something like this, check first what's the middle term. The middle term is 10. What is 1/2 of 10? It's 5. What is 5 squared? It's 25. So the scenario that we have here now is we have a perfect square trinomial. So we don't have to add any number anymore because this is already a perfect square trinomial. All we have to do is factor it. So get the square root of this term, which is x, get 1/2 of this 10, which is 5, copy the sign. Notice that this 5 can also be taken by getting the square root of 25. So this is a perfect square trinomial. Then applying now the square root property, we have x minus 5 equals plus or minus the square root of 27. Notice that 27 can be written as 9 times 3. And the square root of 9 times the square root of 3 is 3 square root of 3. So we can now rewrite this as x minus 5 equals plus or minus 3 square root of 3. And then solving for x now, we add 5 to both sides of the equality to get 5 plus or minus 3 square root of 3. So this is now our solution. There are two roots. One is 5 plus 3 square root of 3, and the other one is 5 minus 3 square root of 3. Okay, let's have another example. Now, this time, we have a coefficient other than 1 in the x squared term. So we still follow the same procedure. You copy the 2x squared minus 7x and isolate the constant at the other side by subtracting 5. And then before you get 1/2 of the middle term, we are going to divide each term first by 2. So that we can cancel this out. We are left with x squared minus 7x over 2 equals negative 5 halves. And then our b now is this part. We need to get 1/2 of 7 halves. So what is 1/2 times 7 halves? That is equal to 7 over 4. That 7 over 4 is what we need to add here. 7 over 4 squared. Since we add 7 over 4 squared at the left, we are going to do the same thing at the right side. So we add 7 over 4 squared. Now the next step is to factor this perfect square trinomial into a square of a binomial. And we know that the first term is the square root of x squared, so we have x. The sign is this minus, and the other one is the square root of 7 over 4 squared, which is 7 over 4. And then at the right side, we have negative 5 over 2 plus 7 squared is 49 over 16. And then let's compute this part. We have negative 5 over 2 plus 49 over 16. The least common denominator is 16, so 16 divided by 2 is 8 times negative 5 is negative 40. 16 divided by 16 is 1 times 49 is 49. So we got 9 over 16. So this part is 9 over 16. What we have now is x minus 7 over 4 squared equals 9 over 16. Now let's continue our computation here. Get the square root of both sides. So we have x minus 7 over 4 equals plus or minus the square root of 9 is 3. The square root of 16 is 4. So finally, our answer would be x equals positive 7 over 4 plus or minus 3 over 4. And simplifying this, we have, if you take the plus sign, you have 7 plus 3 is 10 over 4. Or, if you take the minus sign, 7 minus 4 is 4 over 4. Or 1. So our roots are x equals 5 over 2. The lowest term of 10 over 4 is 5 halves. And x equals 1. So these are our two roots for this equation.